Once again, we have sums and differences over here on the left-hand side. On the right-hand side, we have multiplication, so we have products. These are the last of the 8, or last of all the formulas that we will use. Once again, this is something that if you want to, I don't know what you're planning on getting into in college, this formula sheet that you have right now that you formulated, it's not bad to have if you're going to college and having to take some math classes in college. That's going to involve some sort of trigonometric ideas, because you'll come back to it. The thing, as you get to college, they won't allow you to bring in an identity sheet to sit there and say, oh, we can use this on our tests. Here, I can allow you to do that. When we get into pre-calculus, if those that are taking pre-calculus next year and are able to take the college algebra and trig for college credit, I give you some of these. I won't give you all of them. So I start weaning you off of your formula sheet. And once again, you'll be asked to deal with proving one of these top 4 here. And when you prove these top 4, all that you're doing is you're expanding out your sign of a plus b and your sign of a minus b, or your cosine of a plus b or a cosine of a minus b. You're expanding that out by something that we've already dealt with. 2 of those terms you're going to be able to combine together. 2 of those terms you're always going to be able to cancel out. If I take a look at the cosine of a plus b and the cosine of a minus b, cosine of a plus b is cosine a cosine b minus the sine a sine b. And then when I have cosine a minus b, everything's going to be the same, except for that's going to turn into a plus. So we have cosine a cosine b plus sine a sine b. When I add these together, these 2 cancel out. These 2 combine together. And that will be true for each one of these identities. Let's go to some problems. Solve for theta. We have sine 5 theta minus sine 3 theta is equal to 0. And unfortunately, we cannot combine these 2 together to say, well, that's just the sine of 8 theta. Not able to do that. And the problem we run into is we run into the idea of we have 2 things that are being added or subtracted. It goes back to the idea, if I had x squared plus 2x minus 3 is equal to 0. In that form, I can't solve that equation. I can't solve by, okay, adding 3 to both sides and then dividing by a coefficient, because I have an x squared term and I have an x term. But what we learned to do in algebra is to factor this down to x plus 3 and x minus 1. What we were able to do is change this into a multiplication problem. When I'm in a multiplication problem, we have the multiplication property of 0. The multiplication property 0 says if two or more things are multiplied together to equal 0, one of those things must equal 0. Bless you. All right. If two or more things are equal to 0, multiplied together equals 0, then one of those things must equal 0. Which allows us to sit here and solve this quadratic equation. X plus 3 could equal 0, or x minus 1 could equal 0. So we can get x equals -3, or x is equal to 1. Both of those would be solutions. But in the form x squared plus 2x minus 3, I can't solve that. But in the form x plus 3 times x minus 1, I could solve that. Well, that's what our formulas will allow us to do. We have the sine of 5 theta minus the sine of 3 theta is equal to 0. We have things being added, subtracted, just like up here. We have things being added or subtracted. Do I have a formula that will allow us to move the sine of x minus the sine of y into multiplication? So I looked through those 4 or those 8 I just did. Do I have somewhere, now I'm looking for the sums and differences, which is on the left-hand side. Do I see somewhere, do I have a sine of x minus the sine of y? Yeah, there's one there. What's that equal to, Isaac? Times the sine x minus y divided by 2. Is that it? What my x is 5 theta. What my y is 3 theta. So I'm going to make a substitution. So we have 2 times the cosine of 5 theta plus 3 theta divided by 2 times the sine of 5 theta minus 3 theta divided by 2 is equal to 0. Now, I'll be honest, I don't memorize these. Whenever I have to apply one of these, I look it up. The other ones I know pretty good. These, don't usually use them that much. But there are times where you do have to use them. So if I have 5 theta plus 3 theta, that gives me 8 theta divided by 2. That gives me 4 theta. Five theta minus 3 theta, that gives me 2 theta divided by 2. So what we've been able to do is transform addition into multiplication. Now we can use our multiplication property of 0. If two or more things are multiplied together, they equal 0. One of those two things must equal 0. So we have 2 could equal 0. Cosine of 4 theta could equal 0. Or the sine of theta could equal 0. Now the first one, 2 is equal to 0, does not mean anything because that's not a true statement. So we don't get any solutions out of this. If you say that, yeah, 2 must be a solution, then you give me $2, I give you $0, and we'll call it even. Even though that'll only buy you a half gallon of gas these days. Won't get you very far. But we have the next one, cosine of 4 theta is equal to 0. We need to solve for theta. Got to get rid of cosine. How do we get rid of cosine, Vanessa? Inverse cosine. So we take our inverse cosine of 0. You get what, Jaden? 90. But we took the inverse cosine, so we get a second solution. Inverse cosine, we get 90 degrees. What's our second solution? Inverse cosine. What do we get for our second solution? Inverse cosine. Get two solutions. Principal value, and it's what? Opposite, negative 90. So we have 4 theta is equal to negative 90. So we can divide through by 4, by 4, by 4, by 4. So we have theta is equal to 90 divided by 4, 22.5, plus or minus the period n, or negative 22.5 plus or minus the period n. Our b value is a value of 4. So Ethan Stutz, what would be the period then? 90, there you go. Kick the cobwebs out. So we have plus or minus 90 n. Period is 360 divided by our b value. Over here we have the inverse sine. Our sine of theta is equal to 0. We can take our inverse sine. So we have the inverse sine of 0. Is what, Ella? 0. And then we have to worry about a second solution, which would be what? Inverse sine? Not 360. 180. Because you have to do it supplement. Okay, the inverse sine, or the principal value, which is 0, then it's supplement. Well, what angle do we add to 0 to get 180? Well, that's 180. Our b value is a value of 1, so we have plus or minus 360 n. So we have 4 general solutions that we can come up with that will solve our equation. Rewrite as the sum or differences of sine and cosine of positive angles. What we have is we have products here. We have products, and we will move it into sum and differences. So what we have is we have 2 sine of 40, cosine of 60. So on my list that I wrote down, my products are on the right-hand side. I'm looking for, on the right-hand side, do I have 2 sine of an angle times the cosine of a second angle? And I want to take that from the right and move it back to the left. So I'm looking at the right-hand side. I have 8 of them on the right-hand side. I'm looking for the easiest one to work with, which is probably the top 4. Do I have sine, 2 sine of theta, or A, times the cosine of B? And I want to take that from the right-hand side and move it to the left. So wherever you see an A, I have my 40. Wherever you see a B, you have your 60. So you're substituting in for your A and B and moving it back to the left. And it so happens to be the first one that we just proved. So move it from the right back to the left. The very first one that we worked on, I have 40 here, I have 60 here. So I just put in my 40 and my 60. Sine 40 plus 60 plus the sine of 40 minus 60. So we have sine of 100 plus the sine of negative 20. But what I ask you there is to write it as sums and differences of angles that are positive. I have sine of 100 that is positive, but I have a sine of negative 20. We have a sine of negative 20, which is not positive. How can we make that angle positive? Well, this goes back to odd and even functions. The odd and even functions. If we took the cosine and the sine and we rated them as odd and even, sine was what and cosine was what? The sine, was it odd or even? Was the cosine or odd or even? Goes back to our angle additions. When we dealt with our angle addition, we dealt with the odd and even. What was the sine? Sine was an odd. Cosine was what? Even. Which means when we are an even function, the cosine of negative 30 is equal to the cosine of 30 degrees. Opposites give you equal values. When we have the sine of negative 30, this is going to equal negative sine of 30. So when I have a negative with the sine, it will come out front. When I have a negative with the cosine, I could just erase it, because the cosine of negative 30 is going to equal the cosine of 30. So this negative sign, what we can do is move it out front. So we have sine of 100 plus the negative sine of 20, or I can write the minus sine of 20. Either one is correct. Last type of problem. Rewrite the sum product as, or rewrite the sum as a product. So what we have here is we have addition, we have the left-hand side, and we want to move that to the right-hand side. So I'm looking for one that has cosine of x plus the cosine of y. and I want to move that to the right-hand side where my x is a value of 30, my y is a value of 80. So I'm going to sub in for 30 for x and 80 for y. Go ahead. Find your cosine x plus cosine y. Which is the second from the bottom. Which is x plus y divided by 2 and x minus y divided by 2. Put in your 30, put in your 50. So we have what with the first one, Lucas? 30 plus 50 divided by 2? 55. Second one? Negative 25. 30 minus 50. Oh, is it 80? My bad. There we go. Cosine of negative 25. Okay, so we have cosine of 55 times the cosine of negative 25. But once again, we have a negative angle there. But we now have the cosine. So we have the cosine of negative 30 is equal to the cosine of 30 because it is an even function. So the cosine of negative 25 is going to equal the cosine of 25. So we can have just sort of like the eraser postulate. So we have cosine of 55 times the cosine of 25. In your homework today, you have on page 144 to 145, you have 3 sections of homework. The first section, I like these problems right here. Problems 1 to 12, you have the multiples of 3. I like that section there. The second section, which is 13 through 24. That's these problems here. The last section, problem number 27. It's like that problem there. You can stop at 27. It says 3 to 39, just stop at 27. So that problem's 3 to 27 multiples of 3. Once again, tomorrow, Wednesday, we will have worksheets that will combine, sort of review what we did prior to break with half angles and double angles. So you'll get to rekindle your fond memories of dealing with half and double angles, along with our angle addition formulas here. So we have a couple days of review of these ideas, review day on Thursday and quiz on Friday. So no more new material with respect to trig identities. QED is done. Outside of just going over types of problems we're reviewing. Questions? All right, last 4 minutes are yours.